Hello everyone, I'm Gita. I'm going to explain our study about deep learning-based survival analysis to predict boiler feed pump reliability on coal-fired power plant. It's important to determine when equipment shows signs of damage and the chance of the occurrence of the symptoms or failure at the time t. This information is used to perform the reliability management of a system. Survival analysis is a great improvement of mathematical statistics. It can predict the probability of the event occurrence at each time point by gives the information of the observing object. Many researchers studying survival analysis due to the cruciality of the application. There are many works of survival analysis from the view of traditional statistic methodology. Choke proportional hazard method and its variants such as the lasso chokes assume specific stochastic processes or best distribution with semi-parametric scaling coefficients for fine-tuning the final survival rate prediction. Exponential distribution and Weibull distribution presume distributional forms for the survival rate function, which might not generalize very well in the real-world situations. These models endure with several limitations when the objective is to get a precise estimation. The distribution chosen in the model the data make it hard to provide accurate prediction in terms of survival time. Choke's model used the proportional hazard assumption or PHA that constrain the model in a way that effect of a given feature does not vary over time. That is a restrictive condition in practice. There are several models that try to overcome the limitation of PHA, such as the stratified chokes model and multi-touch logistic regression model or MTLR, which introduce multiple logistic regression to model survival after a given time. This paper proposed a deep learning method for survival analysis based on multitask learning to predict boiler feed pump reliability on coal-fired power plant. Deep serve empower better generalization because the model can account for the temporal aspect of the predictions. In this study, we try to implement deep learning method for survival analysis based on multitask learning to predict boiler feed pump reliability on coal-fired power plant. The core content index metric or C-index will be computed to compare the deep serve model result with choke proportional hazard model or choke PH model. The survival function and cumulative function will be demonstrated using the deep serve method to get the probability of the boiler feed pump operating properly and also show the equipment failure risk. Then the prediction of PFP condition can be obtained. Survival and reliability analysis are specialized fields of mathematical statistics who are developed to deal with the time-to-event random variables. Two important measures that are always used in survival analysis is first survival function, the probability that the object can survive for more than a certain time, and it can be expressed in the equation number 1. And second is hazard function, the rate of occurrence of an event immediately after the object survives for a certain time, and it can express in the equation number 2. Relationship between the survival function, hazard function, and cumulative hazard function is expressed in equation number 3. There are several terms in the survival analysis study. First, objects. They can be item, equipment, sensors, components, and etc. And event is the result of an experiment. In the case of event reliability, it can be expressed as a failure, repair, warranty claim, and etc. And time in the form of the study period. the time of the event occurred, the duration of event occurred, and there are random variables. The random variables are useful in representing the outcome of the uncertain events. And figure 1 shows us about the survival analysis study. Next is deep learning. Multi-layer perceptron, or MLP, are one particular class of artificial neural network consisting of more than one perceptron. MLPs consists of an input layer, output layer, and an arbitrary number of hidden layers. The hidden layers are an integral part of the architecture when the nonlinear transformation of the input data takes place. The ability to learn the highly complex data increases with the number of hidden layers at the expense of computational time. The network takes a very long time to train to adjust the weight of the network to get the desired output. And the figure 2 shows us the representation of the neural network. Deep learning developments and improved hardware architecture have yielded a promising result in applying neural network to survival analysis. First, a hierarchical generative model called deep survival analysis using deep exponential families to capture the dependencies between the covariatives and the failure time. Second, DeepSurf, a deep neural network extension of the GPH model to effectively model complex interaction between the covariative and risk of failure. And the third is the fully parametric survival model to compute the risk score and the survival function of each subject for personalized survival analysis called RNN-SURF. And the fourth is the recurrent survival analysis that combines deep learning to model the conditional probability of each event for each sample and survival analysis that handles tensoring. These are the material and method DeepSurf for modeling sequence data. First, chop proportional hazard, or CHOP-PH. We know to improve performance in survival analysis, need addition of predictor variables. And chop proportional hazard, or CHOP-PH, is commonly used method to perform survival analysis involving predictor variables. And the chop proportional hazard model is a semi-parametric model that focuses on modeling the hazard function, and it's said to be semi-parametric because the baseline hazard expressed as t does not require following a certain distribution. And the CHOP-PH model still uses a linear relationship between the predictor variables and response variables. And this model fails to capture nonlinear relationships, and the consequences can result in unsatisfactory performance. And we move to deep survival, or we can call it DeepSurf. DeepSurf is a deep feed-forward neural network that predicts the impact of the predictor variable on the hazard rate parameters by the network weight. The use of deep learning to build the survival models can capture nonlinear relationships, and DeepSurf uses a deep learning architecture via multi-layer perceptron, and DeepSurf provides much flexibility in modeling without relying on the assumption of the CHOP-PH model. And the main component of DeepSurf is first the input to the network is a predictor of observation data. The hidden layer network consists of the layer of interconnected nodes followed by a dropout layer, and the network's output X is a single node with a linear activation function that estimates the risk function of the CHOP-PH model. And the DeepSurf training process has an objective function to calculate the average negative log partial likelihood of CHOP-PH. And figure 3 is show us a generic LSTM unit. The result and analysis. The data that we use for this analysis is the anomaly of BFP mechanical text sensor data based on the 95% quantile of the autoencoder's upper limit. The number of events during the 2019 observation period was 111 events. And table 1 shows us the snippet of anomaly occurrence data in BFP mechanical text sensors. For simulation, first we do the pre-processing data that used for this study before statistical feature extraction. First, we do filter data every 5 minutes, and second, filter data for data that has a current above 3,500, and we perform data scaling with min-max scaling. So all the data has the same units, and namely with a range of 0 to 1. The second is the predictive variable that used for modeling is statistical feature extraction, such as mean, median, variance, interquartile range, skewness, kurtosis, that the statistical variables were obtained from the condition of the data pattern before the event occurred. And then we do compare the modeling between the chalk pH and deep surf using predictor variable based on statistical feature extraction from pre-processed data. The criteria to compare between the chalk pH and deep surf model is the C index. And the higher of the C index value, the better the model. And table 2 shows us the C index result for chalk pH and deep surf model. And we can see the deep surf give the higher of the C index. So you can say that the deep surf has a better model. Survival function graph in figure 4 and figure 5 show the probability of the equipment operating properly is less than 20% on day 100, while the cumulative hazard function graph shows that the risk of equipment failure will increase up to 2 times. For the conclusion, this paper comprehensively presents the comparison of the survival analysis modeling using the chalk pH method and the deep survival method is using deep learning via multi-layer perceptron architecture. And the result of the experiments show that the deep survival method, deep learning via multi-layer perceptron architecture, give a higher C index than the chalk pH method. That means the deep survival give a better modeling result. The study success to perform the prediction of boiler feed pump reliability on the coal-fired power plant using the deep surf method. The survival and cumulative hazard function that calculate using the deep surf method show the probability of the BXP operating properly is less than 20% on day 100, and the risk of BFP failure will increase up to 2 times. And deep survival analyzing using deep learning via multi-layer perceptron architecture provides a lot of flexibility in modeling without relying on the assumption of the chalk pH model. That's the explanation of our study. Thank you.